Hi viewers, I am Dr. C. Devi Shyamala Mary, Assistant Professor, St.Joseph College of Arts and Science. Today we learn about trigonometric identities. In this sum and difference identities, using this sum and difference identities, we can solve sine, cosine and tangent functions. First we see cosine function. If alpha and beta represent the measures of two angles, then the following identities holds for all values of alpha and beta. Cos of alpha plus beta equal to cos alpha cos beta minus sin alpha sin beta. Cos of alpha minus beta equal to cos alpha cos beta plus sin alpha sin beta. Now we see example. Find cos 75 degree from values of the functions of 30 degree and 45 degree. So we know the values of 30 degree and 45 degree, but we don't know the value for 75 degree. So cos 75 can be written as cos of 30 plus 45 degree. So this is in the form of cos of alpha plus beta. So we have the identity cos of alpha plus beta equal to cos alpha cos beta minus sin alpha sin beta. Using this identity we can write cos 75 degree can be written as cos of 30 plus 45, which is equal to cos 30 cos 45 minus sin 30 sin 45. Now you substitute the values for cos 30 cos 45 minus sin 30 sin 45. That is root 3 by 2 into 1 by root 2 minus 1 by 2 into 1 by root 2. In the first term, we multiply and divide by root 2 minus, similarly in the second term also we multiply and divide by root 2, then only we get the same denominator. So root 3 into root 2 divided by 4 minus root 2 divided by 4. So we have root 6 by 4 minus root 2 divided by 4. Now take the values of root 6 and root 2. When you subtract these two, we have 1.0353 divided by 4. When you divide this one, we have 0.2588. So cos 75 degree equal to this one. So similarly we see sine function. If alpha and beta represents the measures of two angles, then the following identities holds for all the values of alpha and beta. Sine of alpha plus beta, which is equal to sin alpha cos beta plus sin beta cos alpha. Sin of alpha minus beta equal to sin alpha cos beta minus cos alpha sin beta. Now we see example for this. Find sin 15 degree. So sin 15 degree can be written as 45 minus 30. Sin of 45 minus 30. So this is in the form of sin of alpha minus beta, which is equal to sin alpha cos beta minus cos alpha sin beta. So you substitute instead of alpha and beta 45 degree and 30 degree. We have sin 45 cos 30 minus cos 45 degree sin 30. Now you substitute the value. When you simplify these, we have root 6 minus root 2 divided by 4. So which is equivalent to 0.2588. So sin 15 degree is equivalent to 0.2588. Next we see tangent function. Tan of alpha plus beta equal to tan alpha plus tan beta by 1 minus tan alpha tan beta. Tan of alpha minus beta equal to tan alpha minus tan beta divided by 1 plus tan alpha tan beta. Next we see problem. Find tan 15 degree. Tan 15 degree can be written as tan of 45 degree minus 30 degree. Now this is in the form of tan of alpha minus beta. So use the identity tan alpha minus tan beta divided by 1 plus tan alpha tan beta. Now substitute the value for alpha and beta. We have tan 45 degree minus tan 30 degree divided by 1 plus tan 45 degree tan 30 degree. Tan 45 degree is 1 minus tan 30 degree is 1 by root 3. So in the second term you multiply and divide by root 3. We have 1 minus root 3 divided by 3. Similarly in the denominator 1 plus tan 45 is 1 and tan 30 degree is 1 by root 3. In the denominator also you multiply and divide by root 3. So we have 1 plus root 3 divided by 3. When you simplify this one, take the cross multiplication. So 3 minus root 3 divided by 3 whole divided by 3 plus root 3 divided by 3. In the 3 will get cancelled. So we have 3 minus root 3 by 3 plus root 3. In the numerator and denominator we have to multiply by the conjugate. So 3 minus root 3 is a conjugate. So both numerator and denominator you multiply by this. We have 9 minus 6 root 3 plus 3 divided by 9 minus 3. When you simplify this one we have 0.262. So tan 15 degrees equivalent to 0.262. Similarly we can find tan 105 degree. Use the same formula, tan of alpha plus beta. Use this identity. So this can be right, tan 45 degree plus tan 60 degree divided by 1 plus tan 45 and tan 60 degree. So you must substitute the values. When you simplify this one we have minus 3.7321. So tan 105 degree is equivalent to minus 3.7321. So using the identities we can verify this problem. Cot x is equal to tan of pi by 2 minus x. So we can use the verification. So left hand side we have cot x, in the right hand side we have tan of pi by 2 minus x. So tan of pi by 2 minus x can be written as sin of pi by 2 minus x by cos of pi by 2 minus x. So use the identity sin of alpha minus beta. In the denominator we have cos of alpha minus beta. So in the numerator sin alpha sin cos beta minus cos alpha sin beta. In the denominator we have cos alpha cos beta plus sin alpha sin beta. Now you substitute the value of sin pi by 2 and cos pi by 2. Sin pi by 2 is 1 and cos pi by 2 is 0. So when you simplify the right hand side we have cos x by sin x. So that is equal to cot x. Cot x is equal to cot x. So cot x can be written as tan of pi by 2 minus x is equal to cot x. So we prove the verification. Thank you.